Alright, so before we talked about adding, subtracting, and multiplying radicals. Now we're going to talk about dividing them. And we do this a little bit differently. We simplify more than we actually divide. So I'll show you an example. First type we're going to do is the type that only has one root in the denominator. The square root of 5 on the bottom of the fraction is the only thing that's a problem in this expression. So we need to get rid of it. And when there's only one square root in the bottom, you can simply multiply by the square root that you want to cancel out, which for us is the square root of 5. Now this is a fraction, so whatever you do on the bottom, you need to make sure you also do on the top. Since there's two terms on the top, we're going to be distributing a little bit. So square root of 5 times 6 is just 6 square roots of 5. Square root of 5 times negative square root of 7, if you remember from yesterday, is minus square root of 7 times 5, which is 35. On the bottom, 5 square root of 5 times square root of 5 is 5 square root of 5 times 5, which is 25. Now that's kind of nice because 25 is a perfect square. That's what happens when you do this. So I still have the same thing on the top, but the square root of 25 is actually 5. So on the bottom, now I'm just left with a number. So I have 6 square root of 5 minus square root of 35. None of that simplifies, so we're just going to leave it just like it is, over 5 times 5 is 25. Now even though this doesn't look a whole lot simpler, there's no more radical in the denominator, which is what we really care about. So this is the answer for this one. Now with a square root, that's nice and easy. Let's talk about something that's not a square root. So for instance, here we've got some cube roots. Now, first thing I would do is rewrite the denominator a little bit. If I were to use a factor tree here, 4 is actually 2 times 2. So I'm going to write it like that to start. So I've left the top exactly the same. On the bottom, 4 has just become 2 times 2. Now I did that so I could see what I was going to need to be able to cancel this out. This is a cube root. We're always going to multiply to try to rationalize, so I have to multiply it by another cube root. If you remember your multiplication rules, the roots have to be the same for you to be able to put them together. I also know I need a group of 3 to pull out of a cube root. Well, I have 1, 2. I just need one more to have a group of 3. So I'm going to multiply by a cube root of 2. Now again, on the top, we're going to be distributing a little. So cube root of 2 times negative 4 is negative 4 cube root of 2. Cube root of 2 times cube root of 2 is cube root of 2 times 2, which is 4. On the bottom, now I have the cube root of 2 times 2 times 2, which you could write it as 8. Or you can leave it like this because now I have my group of 3. That means that I can pull out a 2. So top is still exactly the same. I can't simplify anything here. There's no groups of 3 to pull out. And on the bottom, cube root of 2 times 2 times 2 is 2. And again, once we have no more radicals in the bottom of our fraction, we're pretty much done. So that's the answer. Now there's only one more type of question you might have to rationalize, which is something that has 2 terms in the denominator. So when you have something like this, you can't just multiply by the square root of 7, because you'll have to distribute, and you'll end up having a square root of 7 here, so it won't cancel out. What we have to do is multiply by the conjugate, which you might remember from polynomials. What that means is we need to change the sign in front of the radical. I'll write that down for you. So I'm still going to have this minus 5 because that doesn't have a radical in it. But this 10 square root of 7 needs to be a negative 10 square root of 7. So that's what makes it the conjugate, is that the sign in front of the radical has changed. Now we have an awful lot of distributing to do here, but you know how to multiply. We did that yesterday. So 8 times negative 10 square root of 7 is negative 80 square root of 7. 8 times negative 5 is negative 40. Negative 7 times negative 10 square root of 7, well, a negative times a negative becomes a plus 10. 7 times 7 is 49 under the square root. You can simplify that now, or you can come back to it later. Negative square root of 5 times negative 5 is plus 5 square root of 7. So that takes care of the top. We'll simplify all that in a minute. I just want to get the multiplying out of the way. 10 square root of 7 times negative 10 square root of 7 is negative 100. Square root of 7 times 7 is 49. 10 square root of 7 times negative 5 is negative 50 square root of 7. Negative 5 times negative 10 square root of 7 is plus 50 square root of 7. And negative 5 times negative 5 is plus 25. Now the simplifying is where this really gets good. So on the top, let's see, some like terms. I have negative 80 square root of 7 and positive 5 square root of 7. That's negative 75 square root of 7. I have a minus 40. I have a plus 10. Square root of 49 is 7. So we're going to multiply that. On the bottom, and this was the whole point, these terms cancel out. Negative 50 square root of 7, positive 50 square root of 7, those are gone. I have my negative 100. Square root of 49 is 7. And I have a plus 25. So now I can simplify even further on the top. I still have negative 75 square root of 7. I have negative 40. I have 10 times 7, which is 70. On the bottom, negative 100 times 7 is negative 700. Big numbers, but you'll always have your calculator. And we still have a plus 25. So now I have some like terms I can combine. Still have a negative 75 square root of 7. Negative 40 plus 70 is a plus 30. And on the bottom, negative 700 plus 25, feel free to use your calculator if you need to, is negative 675. Now this one is kind of tricky because there is one last thing that we can do to simplify. If I look at all these numbers, negative 75, 30, and negative 675, they have a greatest common factor. It happens to be 15. So you need to divide that out. Negative 75 divided by 15 is negative 5, square root of 7. Notice the square root didn't change at all. 30 divided by 15 is 2. Negative 675 divided by 15, using my calculator, those are big numbers, is 45. Negative 45. That's perfectly fine. You may also see, because we don't want this negative in the denominator, all the signs changed. So it could be 5 square root of 7 minus 2 over positive 45. Either one is fine. You're probably more likely to see this one.